Hi everyone, in this video we'll talk about math module. Let's get started. There are many functions in math module. In this video we'll take just 4 of them. Absolute function, accumulate n function, inverse cosine function, inverse cosh function. Let's start with absolute function. This function computes the absolute value of a tensor. Let's say we have a tensor with just one element, which is -2. If we apply absolute value function on this tensor, this function will return a tensor with just one element as well, which is 2. The output tensor has the same type as the input tensor, and we can apply this function on a tensor of complex numbers. Let's say we have a tensor with just one element, which is 2 plus 3j. If we apply absolute value on this complex number, the result equals to square root of 2 square, which is 4, plus 3 square, which is 9. The last thing you should know that there are just 2 arguments in this absolute function. X argument, which is a tensor or sparse tensor of type float 16, float 32, float 64, integer 32, integer 64, complex 64, or complex 128. And the second argument name, it is optional argument. An absolute function returns a tensor or sparse tensor of the same size, type, and sparsity as x with absolute values. Note, for complex 64 or complex 128 input, the returned tensor will be of type float 32 or float 64 respectively. Now let's go to accumulate n function. This function returns the element-wise sum of a list of tensors. Let's say we have 2 tensors. Here is the first one and the second one, and we will apply accumulate n function on these 2 tensors. Now let's compute the result. 1 plus 3, the result equal to 4, and 2 plus 4, the result equal to 6, and 5 plus 0, the result equal to 5, and 0 plus 6, the result equal to 6. The last thing you should know that there are 4 arguments in accumulate n function. The first one is inputs argument, which is a list of tensor objects, each with the same shape and type. The second argument, shape, which is an expected shape of elements of inputs. It is optional argument. The next argument, tensor dtype, which is an expected data type of inputs. It is optional argument. The last argument, name, which is the name of the operation, is optional argument. And the accumulate n function returns a tensor of same shape and type as the elements of inputs. Now let's go to inverse cosine function. This function computes inverse cosine of tensor element-wise. The first thing you should know that the input range is between -1 and 1, and the output has a range of 0 to pi. So let's say we have a tensor x, and to convert all elements inside this tensor to be between -1 and 1, we will apply cosine function on tensor x. So now we have a tensor y. The values of all elements in tensor y will be between -1 and 1. Now if we apply inverse cosine function on tensor y, the result equal to tensor x. The values of the elements in this tensor will be between 0 and pi. The last thing you should know that there are just 2 arguments in this function. X argument, which is a tensor, the type of this tensor must be one of the following types: b float 16, half, float 32, float 64, unsigned integer 8, integer 8, integer 16, integer 32, integer 64, complex 64, complex 128, string. The second argument name, it is optional argument. The inverse cosine function returns a tensor has the same type as x. Now let's go to inverse cosh function or inverse hyperbolic cosine. This function computes inverse hyperbolic cosine of x element-wise. It takes a tensor as an argument and computes inverse hyperbolic cosine of every element in this tensor. The input range must be between 1 and infinity. This function returns none if the input lies outside the range. The last thing you should know that there are just two arguments in this function. The first one, x argument, which is a tensor. This tensor must be one of the following types: be float 16, half, float 32, float 64, complex 64, complex 128. The second argument, name, which is optional argument. First, let's import tensorflow. After that, let's make a tensor x. So x equal to tf.constant, open a parenthesis. Let's say we have just two elements in tensor x. Let's say we have just two elements in this tensor, so open square brackets, and then let's put the first element, which is minus 2.5, comma, and the second element is 3.9. Now let's take the absolute value of this tensor. So tf.math_absolute value, ABS, open parenthesis, and here we will put tensor x. And here's the result, which is a tensor as well. The first element in the output tensor, which is 2.5, it is the absolute value of the first element in tensor x, which is minus 2.5. And the second element in the output tensor, it is the absolute value of the second element in tensor x, which is the 3.9 as well. Now let's make a tensor of complex numbers. Let's say the first element equal to minus 2.5 plus 3j, and the second element equal to 3.9 plus 2j. Now let's see the results. As you can see here, the output is a tensor, and the shape of this tensor same as the shape of tensor x, and the type of the output tensor, d-type, equal to float 64. Let's make the data type of tensor x equal to complex 64. So, the data type of the output tensor equal to float 32, as we said before. Now let's change it to complex 128. Let's run this. As you can see here, the data type of the output tensor equal to float 64. So now let's make a sparse tensor, which represents this dense tensor. Now if we apply absolute function on this sparse tensor, the result equal to sparse tensor as well. Now let's make two tensors, A and B. A equal to tensorflow.constant, open parenthesis, open square brackets, 1, 2. This is the first row in tensor, comma, open square brackets, 3, 4. This is the second row in this tensor. Let's make tensor B. B equal to tensorflow.constant, now let's apply accumulate and function on these two tensors. So tensorflow.math_accumulate, open parenthesis, open square brackets. As we said before, input's argument is just a list of tensor objects, each with the same shape and type. Now let's type shape argument equal to, open square brackets. Now let's put the shape of elements of inputs, which is 2, 2. comma, tensor d type equal to tensorflow.integer32. Now if we change the data type of tensor A to integer 64 and the data type of tensor B to integer 64 and set none to tensor underscore data type, so the data type of the output tensor equal to integer 64, which is the same data type as the inputs. If the inputs don't all have the same shape and data type, so this function will return an error. So let's change data type of tensor B to integer 32. As you can see here, the accumulate and function returns error. Now let's apply inverse cosine function on this tensor. So let's type tf tensorflow dot math module dot inverse cosine function open parenthesis x. Now let's run this. As you can see here, inverse cosine function returns a tensor. The shape of this tensor same as the shape of tensor x, and the data type of output tensor has the same type as tensor x, which is a float 32 here. As we said before, the values of input tensor must be between -1 and 1. So if any value in the input tensor lies outside this range, the inverse cosine function will return none corresponding to this value. As you can see here, the value of this element in tensor x lies outside the range. So the cosine inverse function returns none corresponding to this value. Now let's apply inverse cosh function. Tensorflow dot inverse cosh function open parenthesis x. Run. As you can see here, the output of this function is just a tensor, and the shape of this tensor same as the shape of tensor x, and the data type of this tensor same as the type of tensor x. So if we change the data type of tensor x to float 64, the data type of the output tensor will change to float 64 as well. As you can see here, here is the element of tensor x, -2, -0.5, 1, 0.2, 200, 10,000, and the last one, infinity. Now let's apply inverse cosh function on tensor x. tf.inverse cosh open parenthesis x. As we said before, the input range must be between 1 and infinity. So let's take the first element, -2, which is outside the range. So inverse cosh function will return none. And the second element, -0.5, which is outside the range, none. The next element, 1, which is inside this range, so the output equal to 0. The next element, 1.2, inside this range, so the output 0.6. The next element, 200, which is inside this range, so the output equal to 5.99. The next element, 10,000, which is inside this range, so the output 9.9. The last element, infinity, which is inside this range, so the output is infinity. Thanks for watching.